All right, last thing that we need to learn in our bonding unit is how we handle formulas for writing covalent compounds. It's very, very easy to do, as you will see, so we don't have to spend very much time on it. I think you will be pleasantly surprised by how simple it is. Remember that covalent compounds are made up of two nonmetals, and what they're doing is sharing electrons. Now, before we talk about how we're going to handle covalent compounds, we want to talk just to kind of remember what we do for ionic compounds. Remember, an ionic compound is formed by the transfer of electrons, and when that happens, we form a positive cation and a negative anion, and then those two ions with opposite charges are attracted. And they go together in these perfect compounds that always result in a neutral charge. So for ionic compounds, a metal and a nonmetal, you have to worry about charges. Remember, covalent compounds are two nonmetals and there are no charges because there's no transfer of electrons. They're just going to share their electrons. So for covalent compounds, the tricky part about them is that there are multiple combinations possible for the same two nonmetals. For example, let's consider carbon and oxygen. Just right off the top of our heads, we know that there's two chemicals that are made up of both of those. There's carbon monoxide, which is one carbon and one oxygen, and there's carbon dioxide. So a carbon and two oxygens. So you have to specify the version that you are looking for. Again, when we dealt with ionic compounds, there was only one possible combination to get that perfect ratio to make a neutral compound. In covalent compounds, there's lots of options, so we have to specify the number present in the name. And the way we do that is by using prefixes. This right here, a prefix. Remember that prefixes refer to words that go in front. Okay, now what I want you to do is get out your periodic table, and I want you to write this table down on your periodic table. Go ahead and pause the video for a second. Get that taken care of. Get that written down on your periodic table, either on the front or the back. It doesn't matter, but write this down. Okay, good. So you have that all written down. Again, you were supposed to pause the video, so get that all written down. And now let's go on to how we're going to write formulas for covalent compounds. Again, it is very easy. You do not need to worry about charges. Okay, there aren't any, right? Remember that they are sharing their electrons, so there's no transfer of electrons. There's no creation of a positive or negative ion. Now, what you will do is you're going to identify both of the nonmetals, and then you're going to write their symbols. Now, here's the thing that's a little bit tricky. The second nonmetal will have its name ending changed to "ide." Remember how we did that for ionic compounds? That's the same here. That "ide" ending lets us know that the compound is done. It's kind of like a way to say we're done with the name. So when we go to look for the elements, you have to kind of keep that in mind. So let's look at these two examples. Right here we have dinitrogen trioxide. So hopefully you recognize in there the name nitrogen and also oxide. So nitrogen is going to be N, obviously, and then oxide is O. Okay. Now let's look at bromine pentafluoride. Again, we're going to identify the elements that are present. So the first nonmetal is bromine. And the second nonmetal is this fluoride. And again, you're not going to find the word fluoride on the periodic table, but you will find the word fluorine. So bromine is Br, and then fluoride is the same as fluorine. Okay, so again, we identify the two nonmetals that are present. Then last, all you have to do is look at the prefixes. So we have dinitrogen trioxide, so we'll bring our N and our O and our Br and our F from the other side. And now let's check out those prefixes. Again, this is why I had you write them down. So we have di as a prefix. Let's go back really quick and look at our table. The prefix di right here means 2. So all we're going to do is add a 2 after the nitrogen as a little subscript, okay? And then it says trioxide. So here's our other prefix. Remember what tri prefix means? Like a tricycle. All right, let's go back and look at your chart on your periodic table. Tri refers to 3. See? So easy. So then we just put a 3 after the oxygen. All right, let's try it for bromine pentafluoride. Again, remember we already identified the bromine and the fluorine or what's present. So notice that it just says bromine and there's no prefix. If a prefix isn't used, you're going to assume that there's just one, okay? So we can write down a 1, or remember that you don't need to write the 1. You can just leave it blank. Either way, it's perfectly fine. Then we have pentafluoride. Do you know what the prefix penta stands for? If not, let's go back and look at our chart. Penta is right here. Penta stands for 5. Whoops. So we go back to our 5. And there we go. We're done. So easy. Identify the elements that are present. Both of them are going to be nonmetals, so they're going to only be in that yellow section to the right on the periodic table. And then just look at the prefixes. So now it's your turn. You're going to go to your assignment, which is writing formulas for covalent compounds, and you are going to do the molecules or the compounds listed. It's on Google Classroom. You get to type directly into the Word document. Please have it done by 3 p.m. today, and that's what I'm going to use to count for your attendance. And then we will review how to do it next week when I see you guys again. Have a great day.